says a simple random sample of 1,200 Americans 20 and over with a proportion of diabetes was found to be 0.115. Okay, so we have a sample of 1,200 Americans and 0.115 of the sample have diabetes. Alright, so this is our p-hat. Our p-hat is 0.115. Alright, I'm going to go ahead and just skip over the checking of conditions here, but we'll just do that. Okay, so it says, what is the standard error for the estimate here? Okay, so our standard error of our estimate, square root p-hat, 1 minus p-hat over n. So p-hat is 0.115, 1 minus p-hat is going to be 0.885. 0.115, 0.885 divided by 1,200. This ends up being 0.0092. That's our standard error. Alright, find the margin of error using a 95% confidence interval. So again, our margin of error for 95% is going to be 1.96 times the standard error. So here, times 1.96. I get my margin of error to be 0.01805, but I'll just we'll just leave it 0.018. That's our margin of error. And so part C says create a 95% confidence interval. So I'm going to have p-hat plus or minus, basically my margin of error. So I have 0.115 plus or minus my margin of error, 0.018. So on the low end, 0.115 minus 0.018 gives me 0.097. Alright, and on the high end, 0.115 plus 0.018 0.133. I'm sorry, yeah. So my 95% confidence interval is 0.097 to 0.133. Alright, so here I say I am 95% confident that the percentage of Americans who have diabetes is between 9.7% and 13.3%. And part D says, according to the Center for Disease Control, nationally, 10.7% of Americans aged 20 or over have diabetes. Does the confidence interval E found support or refute this claim? Okay, so it says they claim, CDC says 10.7% have diabetes. Alright, so our confidence interval goes from 9.7 to 13.3, and 10.7% is inside our interval. Okay, so 10.7% is inside, it's between 9.7 and 13.3. Okay, so that's what we mean by is inside our interval. So so it is plausible that 10.7% of Americans have diabetes. Okay, so it's not unreasonable to see that number there.